Right guys, I'm going to go through 6 coordinate geometry problems, so hopefully these help you understand some of those new concepts we'll be going through. I like to just draw the problem out, so I'm just going to go, well, this is the leftmost because it's got a -2 and that's a 3, so that's -2 and now 3, and so this one is, well, that's right and up, isn't it? So that's 3, 4, and we want the distance, we're wanting this length. And so like what we've gone through in previous videos, you can create a right angle triangle, and so this distance is going to be the square root of this side squared plus this side squared. So that's going to be x2 minus x1, isn't it? So 3 minus 2 squared, right? 3 take away -2, the difference in the x's, plus the difference in the y's, 4 minus 3 squared. So 3 take away -2, well, that's like adding, isn't it? So that's 5 squared, and this is 7 squared, isn't it? So 4 plus 3, and then we square root that whole thing. So on my calculator, I'm going to go 25 plus 49 and square root that answer, 8.6. And that doesn't have any units, it's just calculate the distance, so I'll just put units down there. So that's your first one. So hopefully you got that right. Here's your next one. You can pause the video and give this one a go. So the distance, between those 2 points. So we have -1, -5, and 2, 8. And it doesn't actually matter which order you do these in, because it's actually just distance, so it's just it's always going to be a positive length. So I could actually call this x1 and y1, or I could call this one x1, y1. It does matter in other scenarios though, so let's try and keep it to being that's x2, y2, and we'll call this x1, y1. So in a distance formula, which is x2 minus x1 squared plus y2 minus y1 squared, all square rooted, then this is going to be 2 take away -1 squared plus 8 take away -5 squared, and that is all square rooted. So we're going to get 3 squared plus 8 plus 5 is 13 squared. I think this might come out to be, no, it won't be 5, will it? Let's think of a different right angle triangle. So we have 9 plus 169, and then we square root that, and we get 13.34 units. 13.3 is fine. So that's how you do the distance for those points. Now I want you to calculate the gradient of this line segment, and this is where just sketching what that line is doing comes in handy. So we'll have -9, -3, and to go to this point, well, we'd have to go right by 8 and down 1. So you can actually tell it's probably going to be -1 over 8, isn't it? So we want the gradient of that line segment. So that is, M is rise over run. So rise is y2 minus y1, and run is x2 minus x1. So y2, -4, take away -3, all over -1, take away -9. So -4 plus 3 is -1, and -1 plus 9 is 8. And like I said, it's going to be gradient -1 over 8. It's easy as that. Hopefully you got that one right. Here's your fourth one. Calculate the gradient of this line segment. So I'm going to go -8, 7, and I'd have to go right 5, and I have to go up 10. probably going to have a gradient of 2, isn't it? Sorry, up 10, across 5, so rise over run. So we're going to call this -3, 17. So you can also almost just almost guess the gradient, right? But when they get a little bit more complicated, we need to use this formula. So m is y2 minus y1, 17 minus 7 over x2 minus x1. So that's 10, and that is 5. We have a gradient of 2. M is 2. Okay, 2 more problems. All right, are these points collinear? So if I have if these are all in one line, A, B, and C, they're collinear if the gradient of A to B and A to C is the same. So let's just go A, B, C. And we'll go gradient AB, well, that's going to be rise over run, so that's going to be 7 minus 4. Right, this is the rightmost point, so this is going to be our 2's and this will be our 1's. So 7 minus 4 over 1 minus 0, so the gradient of 3 over 1. All right, gradient of AC. Again, this is further right, so we can call this our 2's again. So that's 10 minus 4. 10 minus 4 over 2 minus 0. Right, there's a difference in our y's over difference in our x's. And we have 6 over 2, which is 3. So A, B, and C are collinear. Right, because the gradient from here to here is the same as gradient from there to there. And so they must be on the same line, right? Otherwise those gradients will be different. All right, and last of all, what's the perpendicular gradient of the line segment that joins these 2 points? Well, what we do for this is we find out what the gradient is. So let's go, this is 0.0, -2, and we've got 2, 7. So across 2, up 9. So it's going to be quite steep, isn't it? So 2, 7. Notice how I'm just trying to get a bit of an intuitive understanding of what's happening. All right, so gradient is rise over run. So 7 minus 2. So 7 take away the other y value over 2 take away the other x value. So we've got 9 over 2, which you can pretty much read off, right? 9 over 2. Now, perpendicular gradient is the opposite gradient. So if you had 2 lines, M and they had a gradient M1 and the other line had a gradient M2, if you multiply the 2 gradients together, you should get -1. So if we know that 1 is 9 over 2, what do I multiply 9 over 2 by to get -1? Well, if I was to multiply 9 over 2 times -2 over 9, well, you can see I'm going to get -18 over 18, which is -1. Or think of it as the 2's will cancel, 9's cancel, and we're left with -1. So if you ever want the perpendicular gradient, you just flip and change the sign. So perpendicular gradient is, well, if we flip 2 over 9 and make it negative. So remember, if this was on a grid, let's just go from origin across 2 and then up 9. Right, so we're dealing with some sort of gradient like that. Well, it makes sense that it's going to be negative. And so let's have a look at what happens when we go down 2 across 9. So down 2 and then across 9. And so it's looking like that. So just think of it as the opposite gradient. So instead of up 9 across 2, think about going down 2 across 9. And that will give you your perpendicular gradient. So hopefully you got at least 5 out of 6, because I understand that this perpendicular gradient could have been a little bit of a challenge. But just remember that rule there, and the perpendicular gradient is the flip and the negative. Nice.